Hello, everyone. This is George Rivera. I'm with T Equipment. Thank you for joining us. We have a great webinar here for you to discuss how to use condition-based maintenance practices to improve your maintenance program. And I'm joined by Frederick Baudar from Fluke. And while we're waiting for any additional people to join, I just wanted to go through a couple slides about our company, and by then we'll have everyone that's going to join, and we'll turn over control over to Frederick. So our company is 16 years old, and we've become a very large stocking distributor. We really do take to heart the slogan, buy from people, not just the internet, and have a qualified staff here to help you. As you can see from this slide, as a national and international distributor, we cover the needs of a wide variety of customer types on the left side, and the right side gives you the product and instrument types we carry, at least in part. We carry over 500,000 products. Our company has invested heavily in making the website a great resource. On the left side here, you can see the filtering capability by specifications to narrow your search. On the right side is a screenshot of an internal portal that we use for better customer service. We're constantly enhancing our website and internal systems to provide a better experience for our customers. So let me turn over the presentation to Frederick. He is a lead product specialist for Fluke, focusing on the reliability and condition monitoring aspects. And he has over 20 years experience and is an electrical and instrumentation engineer by education. He's also a certified thermographer and holds a CMRP certification, Certified Maintenance and Reliability Professional. Frederick, thank you for joining us. Are you there?
Yes, good morning or good afternoon, depending where you are.
Let me turn over the control to you. Okay, so you should have control now.
Okay.
And while he's setting up, if you have any questions, there's a chat window that you can ask any questions to get to during the presentation or after. Or if depending on the question, maybe I'll answer it through the chat, or we'll bring it up at the end. Feel free to take advantage of that. All right, you're all set?
Yes, hang on a second here.
And oh, one other thing, everyone will get a copy.
Give me 1 second.
Everyone will get a copy of the presentation. We'll email it to you. We'll have it a recorded copy as well as a copy of the slide deck.
Okay, can you see as a presentation mode?
No, we just see the, there we go. Now it's in presentation mode.
Okay, I apologize for that. So why don't we start? So again, I'm Frederick Baudar, lead application specialist with the Fluke business. I'm part of what we call the FDS, which is the Fluke Digital System, which is really heavy focus on software, maintenance, and reliability. It's actually a big departure from what the traditional Fluke company has done. And so we, along with some of the tools that we have incorporated software and really also a bunch of different processes within the reliability industry. So we not only as much about the tools itself, but about what do you do with it, what do you do with the data, how you actually consult with customers. So that part of the business is where I belong. So one of the things that we have been trying to do over the past year and a half is, along also with educating our customers and potential customers with tools, we also like to educate them about maintenance and reliability. It has been a heavy focus of our group on this one. So this is what I kind of want to go back a little bit at the beginning. How do you really use a condition-based maintenance practices to either improve a current maintenance program or even start a maintenance program? We do have quite a bit of customers who actually approach us and say, I have no idea, I want to start, but I just don't know where. So we're trying to educate them in that aspect. So I will move forward. So, in order to kind of set up the stage, one of the things that we wanted to do is really provide a definition of condition-based. What we have noticed over the past, especially in the past year, there's a lot of work between IoT, predictive, preventive, condition-based maintenance. And I think then, even to a certain extent, we are even as a company guilty of trying to throw those definitions out there and not really understand what they really mean. So we just want to go back to some of the basics. So when we actually define condition-based maintenance, at least with our organization and with our customers, it's really about maintenance strategy. And it's about a maintenance strategy that really monitor the current condition, so the actual condition of an asset. And you do this either real-time data, historical data, or even previous data than you've had, then you look at it. And what you do really with those data is the idea is to prioritize and optimize the maintenance strategy that you have in order to have the asset perform the way it's supposed to be. Obviously, we're trying to do this ahead of a failure, and try to be preventive and predictive. But it really is not just much more about the traditional calendar or runtime maintenance. It's really a combination of multiple things, both hardware, software, hands-on versus wireless. So there's different technique, different approach that we wanted to talk about it. So when you think about some of the challenges, then maintenance team, regardless of the type of industry they are, there's quite a few of them. And so let's try to focus on a couple of them. The most common that we see, at least that I hear from customers, is really to do a lot more with a lot less. And even in our own business, it's the same thing. I have a team of field service and team of product specialists who report to me, and it seems like we're always pushed to do a lot more with a lot less team members. And it's the same thing within a lot of organization to do that. And so while the cost of downtime it can actually be increased. So one of the aspects then we're trying to look at it is really what are some of the driver of these issues. There's multiple of them, but I wanted to highlight three of the drivers that we have seen. Number one, we even see this in our own industry, is a shifting workforce. And so we have a lot more of the baby boomer, the senior technician and engineer who have retired or will retire. And that generation has often had a tremendous amount of knowledge and since probably 2005 all the way up to 2025, will have to somehow transfer. And so there's got to be a way that we do this to make sure that we do not lose the skills they have acquired and transfer this into the newer generation. Some of the maintenance actually is getting more complex. It's complex in the sense of you have more VFD, is automized, a lot more automated, and a lot of the teams that we see are cross-functional. They work cross-functional, which is really a positive, but they're getting smaller. So that means that previously what instrumentation engineer would do as maybe 2 or 3 responsibility end up being 5 responsibility right now. And it could be cross-functional with different type of technology. It could be electrical, mechanical, or mechanical and thermal, or even others. And the third one is really a common one, is some of the budget are being reduced. And that's usually what we see more and more on a regular basis year over year with some of the matters. And so we want to try to assess some of these and how we can actually help with some of the key driver. So what can actually we do, or what actually the team, the maintenance team can do? Well, they like to do a lot of the things ahead of a failure, ahead of a downtime. There's a few smaller things they can add to bigger things in order to actually be done and be successful in that aspect. A lot of the team that we talk about, the maintenance team, reliability team, are trying to move from reactive to preventive and then predictive. That is great. It requires a lot of work, a lot of organization. It doesn't have to be a very big organization, but it has to be a team that is organized, dedicated, and then can show success and then buy-in from the leadership. So there's a real shift of culture and of how the process of working together is done. And so, but the idea is really to start really small, and I'll repeat this a few times, to start small in order to get some success and move forward. As I mentioned, some of the three things that we're trying to explain, as much as define and trying to move from one to the other: reactive, preventive, and predictive. And quite frankly, what I've seen over the past, at least for sure over the past 2 years, is that there's no necessarily one that is more prevalent than the other. If maintenance organization has actually, based on the number of assets, number of tier, and number of criticality, look at the facility, what they have in order to maintain, having a mix of strategy between reactive, preventive, and predictive is actually fairly healthy. Not every single asset should be on a preventive and predictive. It really has to do with some of these, the failure, the cost, the downtime cost, a number of assets, and a number of points. They can dictate what type of strategy do you want to have for a particular asset, a particular side of your plant or facility, or for that matters in general within the maintenance strategy. And do you have to pick one? No, not really. Actually, you have to pick all three, to be honest with you. I mean, that's from a personal aspect, I think you should pick all three. But obviously, there will be dependent on what the maintenance team wants to do, how comfortable they feel. But we have seen time over and over again, talking to our customers, then having a mix does help refocus their strategy on what they're trying to achieve. So some of the top questions, I wanted to put some top questions and try to see if we can address those questions within this discussion. And some of there's a lot more of these, but at least I put 5 to 7 of them. And those are how to monitor all critical assets in the plant with fewer resources, how you bridge the skill gap, what tools do I begin with or use, how to get the benefit of proactive maintenance without a big program. That's often something the customer tells us to say, we don't have a program, we don't have a big program, how can we get a result out of it? How to justify the cost of the tools and resources that are needed. That's definitely one of the bigger things. Is really we're trying to address this on multiple layers to try to have either ROI with customers, trying to educate them, say, look, if you do those 2, 3 things, I think then you can prove there's a benefit to it. You can prove ROI, and then you can go back to your maintenance manager or to your leadership and then show them the value of actually having invested in tools and resources. How to start a program when we have already 100% people our resource busy with PM and corrective repair, and how to even start or restart a proactive maintenance program. So the way we really often explain initially to customers, and even for that matters internally when I talk to other team within the organization, is really when you think of it, how to monitor asset with your resource. We take the medical industry approach and how they have actually started resolving this and resolving. And the way we do this is they had the statement they often do is that we have we overload with no, we overload with patient request. Patients are really critical, and it really overloads our staff. So we just don't have enough doctors, nurses, and specialists in order to do this. And so the way they have looked at it is the same way that we actually do this from a technology standpoint. I'll take the example when you go to your doctor, to your primary practitioner, your family practitioner. Often you are welcomed by the nurse, and the nurse take a series of questions and also parameters such as temperatures, your weight, your height, and so forth. And then she asks you a few questions about, hey, what's going on, what's happening, and has anything changed? She'll record this data, and essentially that data is passed on directly to your primary doctor. And so he has the ability to see this data before you even go see him. So there's a time saving right there. And that allows them to essentially multitask with multiple patients. And it's once you arrive at the doctor, he already knows what potentially you need to discuss. And then at that point, the doctor, the general practitioner, can decide, yeah, I think this issue is beyond my reach, or you should truly go see a specialist. Well, when you think about a maintenance practice and the way we have approaches it, really from a tool and practice standpoint, is really in three things. Number one is really the nurse is also considered some of the tool there is in the industry about screening. So you really want a screening for potential problem than you currently have. And it could be a handheld, it could be a wireless, it could be any device, but screening on a number of assets. The number two, once you screen, is really about diagnose with common failure and trying to do root cause on those common failures. And based on what you do this, then at that point you can decide, yes, we can repair. No, we cannot repair. We truly need to analyze or have a specialist, like a vibration level 2 or 3, they can really analyze the data and tell us exactly what's going on, what we need to do. So you can see there's a real parallel between the medical industry, how they have approached, and from a tier maintenance approach that we try to promote. And this is actually represented kind of in these two schematics right here on the left side. And I take the example often of rotating machinery, but it really doesn't matter. It could apply for multiple. Where you start from the bottom, so you look on the left side, you start from the bottom and you do a screening. And then from the screening, you screen most or all your assets from a PM standpoint. And then you can quickly see if the asset is healthy or not. Most of the time you'll see then the asset is within the healthy parameters, and they point that's about 80% of them. So you're only focusing about 20% who may have an issue. From the 20% you take, you diagnose these tools, these assets, with some additional tools. And then from there, we're going to find out then the team or engineering maintenance team can actually repair 90% of the one they've diagnosed. So there's maybe 10% of those who are really only a potential issue. And that's where you would bring a specialist, either in thermography, in oil sampling, or anything. And so you really start to break it down where you truly need to focus based on the cost of the machine, the downtime, the importance of the machine within the process or production system. And so that's how we try to approach our customer. And it's the same way from a process perspective than it is from a tool perspective. It also allows teams to enhance their skills and to share skills they may or may not have between team members. So when we think about some of these, the tools, there's a number of tools that you can choose. And really, the way we approach this is not only from an asset perspective, but it's also from where you are really within your maintenance strategy. When you look at here, what you don't see in this graph on the left side with the P&F curve is the design portion. And when you think of it, your maintenance strategy really start at the very beginning. It really start when the asset is first installed and commissioned. That's where we should actually start looking at it. But there's a lot of those installation in facilities who have assets who are 5, 10, 20, 30 years old and have been maintained either on time calendar or on a PM or have not been maintained. So at some point they will be within that range. But really is the idea is it doesn't matter almost where you are. It's really what actually would fit. And so what we often explain to a customer is that don't go crazy and select 5, 6, or 7 different technology at first. What you really want to do is that pick 2 or 3 technology or even one technology that fits your need based on the type of asset and criticality you have. And so, for example, I'll take this as you have a distribution center from a large company. It could be any name of company. They have a number of assets, and often in the distribution center, they have a lot of bearings, a lot of motors, small motors, to move all the box and the parts. And so they could start a program from the get-go with a small team. They would be, hey, we're going to monitor on a regular basis. We're going to take a thermal imager picture of all the control panels and all the motors and all the bearings. That's at the beginning. And you can do this either on a monthly basis or on a quarterly basis. And then you can start looking with a couple of tools. You can start looking, screening, where do you need to spend your time and your resource. And so once you do this and once you find a couple of failures, you may actually decide to have another technology could help you. Say, hey, maybe we need to monitor these few motors with a wireless vibration or with another vibration monitoring. And so this is really what you want to focus on. It is which one and the type based truly on the need in your facility. So when we say which tool you should start with, is there's no right or wrong. Is really is you have to pick the tools then you feel comfortable from a screening perspective. And there's a number of tools in the industry, then you can actually do this. And a lot of them actually fairly easy to use and to be trained and to train another team. And so I often recommend them start small and then grow from there. But the first one is that why don't you get yourself a few screening tools, even if they're wireless or Bluetooth, doesn't matter. And step number 2 is really, again, about what I was saying, is really diagnose. So focus on diagnosing. If you don't have any diagnosing tool, that's fine. There's plenty of companies who offer third-party solution where they can come in your facility. They can actually diagnose for you and provide you with a report where you'll know where to spend your time and essentially your resource and parts if you needed to. And the third aspect is really correct. And often this works very well as an example for vibration where you do a screening. So on a few motors, so imagine you have 10 motors in a certain part of your plant, you're screening all those 10 motors. On out of 10 motors, you may have 2 of them, then really I need to diagnose those motors. I need to find out a little more if I have imbalance, misalignment, or so forth. And then from there, there's 1 or the 2 that truly have a misalignment, and that's where you actually correct the problem. Obviously, this does not apply only to vibration. It applies to multiple types of technology and assets. And the last but not least, which is often what you want to do, is really correct the problem, and not only correct but capture the data. And again, this is part of the second portion. Then I'll be talking about it. Is it really? It's great to have tools, regardless if they're wireless or handheld, however you have them, but it's what you do with the data. So as you start building up your program, the idea is to make sure you select the right tool and technology, but also make sure you start reviewing the data and where those data are going to be actually held. Are you going to keep this on a particular software? Are you going to keep this on the CMMS so you can drive work orders and you can share? And so that is the biggest component also of the one of the biggest component of the PDM program. Then you want to look at it. And we'll talk more towards the end of the presentation about this. So I just took a simple example of a technology selection where you can have a location and efficiency. And obviously, here I described, then you can save definitely money based on what it is and the impact that you can have. But quite frankly, it's not about the money. Yes, it is it's about the ease of use of the tools. It's about where you truly have a need. And if you take a simple office facility or manufacturing, there's a number of places. Then you can start thinking from a process, from an HVAC, from even a building, the building itself, the mechanical room, the utility aspect, and it could be even the temperature inside of the facilities. If my temperature is constantly going up and down, then I potentially have an issue with the VHC system, or maybe it's not properly, the envelope of the building is not properly suited for it. So there's a number of ways that you can look at based on your facility. Obviously, from an industrial perspective, this can be applied just about anywhere. And so that's why we try to help customers, regardless of the market or regardless of the vertical that they are, trying to adapt based on their need. So how to actually get the benefit of predictive maintenance without really a big program? And this is what I've actually started to talk about, it is really, I'll take the three examples that I have here, is really, as a vibration example here, is it, you look at your vibration meter, which is really a screening tool, handheld, fairly easy to use, and you can actually get good basic data. Then you quickly can also share. So I'll take a practical example where I have seen this. When you think if this is a wireless or Bluetooth, you can actually share this with an engineer who may be 500 miles away, because he has the ability to be log in onto the site where you upload the data almost on instantly. Once you do this, is that really either the technician or engineer can really determine if we would need a diagnosing tool. And a vibration tester is really a good one to do this, and it will give you a whole picture of what is truly happening with that particular asset. Am I looking at misalignment? Am I looking at a bearing failure, either early or late stage bearing failures? And then what do I need to do? There's a lot of vibration tester in the industry. They provide you some really, really good data without you being the need to be a vibration specialist. Same thing with thermal imaging, same thing with power monitoring or power quality, and oil analysis. There's a number of things that can be done with a small team or within maintenance team. Then you can actually have an impact on how you actually look at and get the data. And the third portion obviously is we show here the corrective tool, which in this case happened to be a laser alignment, where you can actually really go in from the beginning, say, hey, I think I may have an issue, I don't have any data, all the way to correct the problem within your own team. The same thing can be said also here for thermal application and electrical application, the way we approach. So there's a number of applications where you can use a technology without having really a big program and starting small, and really have an impact on how you actually run your preventive or predictive program. And again, it's really about setup, measure, diagnose, and take action to it, which what are the steps. What I also like to explain to customers is really how we justify the cost of such a program. Have a few maintenance managers have approached me and say, look, my budget has been slashed by 25% this year, year over year. The production has increased, but they slash our budget for whatever reason, and I'm down to you guys. How am I going to justify this to my leadership management, to the plant operation manager, or even to the VP? And often I try to explain to them to go back really to the beginning. Think about a few things. And number one often is really, once you look at your asset, is it what would be the production downtime cost? A lot of these industries, wherever you're located, actually have access to those data, or actually they monitor those data either through a Maximo system, a CMMS system, but they have ways to identify how much it would cost. I did actually the same exercise here within our own facility with the mattress manager. I said, well, if one of the chiller goes down, how much does that cost Fluke? Oh yeah, well it costs so much and so much. Plus you have half of that building will not be able to work, especially the summer or in the winter if we don't have the boiler. Well, we have the same problem. So there's a downtime even in a manufacturing and office environment. So I can only imagine in any industrial, there's really the cost could vary from a few $100s to multi-million dollars. So having that in mind is an important factor. Energy waste. Um, I had recently a customer where I approached them and is a manufacturing environment, and I say, you're running all 5 compressors, and most of them are running at roughly 60 to 70%. It's like, is there any way that instead of running all 5 compressors and using so much energy, you can only run 3 at 80, 90, or 100% of its capacity, because it will sustain, still have the same amount of compressed air without losing anything. And then you have 2 backup generator in case you have an issue, plus you save on energy. And so there's some ways to look at it on how you actually use your energy within a facility. The cost of a machine replacement is a big one. So if you have a 250 horsepower motor, that could cost you $20,000. Is it something then your budgeting team or your planning team are going to let you keep as on the shelf? Well, if it's a tier 1 asset, there's a good chance. But if it's not a tier 1 asset, they may not want to carry that inventory on the shelf. And so you have to look a little bit against what would be the replacement cost and how much is it going to affect your production overall. Maintenance and labor cost. Every time that we have an issue, even here on facility, it always seems to happen at overtime. It's always a Saturday at 2 p.m., or it's always a Sunday, or it's always during the night. It hardly ever is during the day. Go figure. And so that cost right there will also drive budget to be reduced by a number of dollars. And so that's something then you want to look at it, how much it will cost for your maintenance team and for your labor to actually do the replacement of the parts on once it is failed. And the last is really, what if we outsource this? So often is it you may decide to have an electrical or thermal program, basic program, but you're not yet ready, or you don't have the budget of approval to have a vibration program in your system, or you have too many assets that needs to be looked at it, and you just don't have the resource and the time to do this. You could easily outsource to a third party. They would come and actually do this for you, and it may be cost effective, because when you look at it, they'll charge you $8,000 to come for a couple of days, get some good data, a good screening and diagnosing data on your asset. But if you were to do this on your own, it would take you maybe 3 weeks of man hours, and you would be at $12,000 or $15,000. So right there's a cost savings. Now it could be the inverse as well. It could be costing more from outsourcing, and then at that point you would decide to bring a program intern to your team. So those are some of the areas to look at it. Now all of them will be with every single facility, but I think most of the time when we had discussion with customer, they can easily find 2, 3, or 4 of them that really could have an impact on how they approach and how they justify either tools and or resource needed for a program. So how to start a program? That's like the $1 million question that often we get really is, and I think the biggest things that we try when we educate customers is really start small and grow. Often is make a list of all the assets you have, and if you don't know, or even if you already know, what are the critical assets when you look at this? And this is a good opportunity to sit down as a team, both often with the operation, the maintenance, and the reliability team, if you have, and maybe also with the IT team, and say, okay, when we look at the production, what is truly critical? How is it going to affect each of the group? Because each of them are going to have a separate thoughts on it, but they each going to have an impact. And again, the idea is if you start small and grow, it's a lot better than if you try to do all 500 assets and you just completely lost, and you're never going to go buy in or show ROI. Often we say start with a pilot program. Take 5, 7, or 10 assets, which you can look at it on a regular basis. You can monitor, or you want to monitor because they're critical, or a mix, and or a certain part of the plant, and say, okay, we want to go with this. If this works well within the next 3 or 6 months, and we can show a return on investment on this one, then at that point, we'll be glad to implement this into the rest of the manufacturing facility or in multiple sites across the US or globally. The idea is with the smaller one, you have a much better control in order to reduce some of the PM and reduce some of the repair. Because you start monitoring, you start to gather data, so you start to really focus some attention on this, both on the tool and the resource, and say, look, guys, for the next 3 months, we're going to focus. We're not going to forget about the rest of the machine, but we're really going to focus on these one and kind of take a look at it in a deeper dive and see how can this help us in order to apply this on the larger scales. And then one other thing that is really, really important is that it's great at the beginning to get some tools, to get a program going, but because it can be exciting for some of those maintenance teams. It's brand new, you can show improvement, but over time, you really always continuously want to reevaluate what you're doing, either on a monthly basis, on a quarterly basis, but essentially review the machine, see how they're performing, see how your team is performing. Is there a skill gap? Do we missing some training? We have now captured all the processes needed in order to have a good PM. So all these things is a continuous link, training and improvement, and that will help you actually also present this into leadership and get buy-in. So this is why we're saying the solution is train a few machines, you can reduce some of the PM and repair, and you have more time to add more machine to review, and maybe to have some machine as a condition monitoring. Part of the program should also be a mix between the handheld and condition monitoring, which could be either wired or wireless, however you want to do it. So kind of a summary of these of what I've been talking about. It is really how to restart a CBN program. Really focus on set up a new program. So you can set up this one or reset a new one. And you can see on the right side in the top right corner, I had this 3 little essentially screenshot. And what are those? And I'll be glad to provide you those. Those are essentially it's a small, if you want, Excel spreadsheet that we have put together, part of our vibration manual that my colleague John Burnett, who's a level 2 vibration specialist, put together. Is really a way to do an asset criticality revision. And so you look at the entire facility, where you have your asset, where they're located physically, what type of PM are we doing, and how important are they for the production of the facility. And then so you assess essentially a rating, and then from that rating, the second portion is really to decide what type of PM or predictive maintenance program we're going to assign based on the importance of these. And as you walking through this, it becomes very clear where you need to spend your time, your resource, and your money. And the third one is really implementation of that. So that's how kind of overarching view on how you actually kind of reassess what you have been doing and what's important. The number 2, obviously, once you have this, is really select the technology. Decide what you want to do, how you want to measure the comfort level. And for me, the technology selection goes along with the training selection. So you may have a few people who are fairly capable of doing electrical and thermal, but they may not have vibration experience. You can get inexpensive vibration tools, screening, diagnosing, and all they will really need is that, hey, how to learn this, but also a good training. And you can put them into vibration one level training as an example, and that will give them some good sense on what they would need to do. And you bring essentially the knowledge internally. That can often reduce from a training perspective. It can always reduce the cost and potentially outsourcing something that you used to do for the past 10 or 15 years and bringing it home because you trust your technician and engineer. And the third one is really about data management. You can have all the best tools in the world, regardless of the brand, regardless of the color, what you do. But if you don't manage your data, it almost doesn't matter. And this is the biggest piece, the biggest component is really is often my first or second question is really, what are you doing with the data on those either wireless or handheld tools that you're doing, or for that matter with software? Where is it going? And are you doing anything with this? At the end of the day, the goal of this, of any program, is that you have tool and resource that can help you. They understand you have training, but it's really the action that you're going to take based on the data that you collect and where those data are going. This is what a maintenance manager, a plant operation, for that matter, for a VP, are looking for. Is that now that I have invested in tools and resource, I have the data. Who's going to review the data? What do we do with this? What action are we taking? And this is really important. This is probably the biggest piece where we actually, as a corporation, we also like to educate people and also to invest is really, predictive analytics. That's the one that we hear all the time. What are you doing from a software perspective? Then you can help me predict some of the failure on motors, on chillers, on pumps, and so forth with what you have. So when you think of breaking down in three, set up a basic, easy program either with or without a pilot. Select the technology then you need for your applications and assets, as well as the training needs. And look at your data. What are you doing with the data? And so last thing that we often talk about is really how do you actually combine technology? Combining technology is actually a big deal. It goes along with have a good mix of management strategy between reactive, preventive, and predictive. And it can actually help you get a complete picture of the asset issue that you would have. I'll take a recent example. Is within a manufacturing facility. So I approached the maintenance manager, and they say, we haven't done a good PM on this pump and motors. Then it's part of our HVAC system. It just happened to be, I think it was a 20 horsepower motor, direct drive with basic pump. And we looked at it, and he said, look, I've been doing a little bit of the vibration. So I have a handheld and the screening tools that I've been using, and the bearings, both on the non-driving end and on driving end, as well on the pump, seems to be okay. They have not shown any indication of really failure to the point that I need to remove that motor. So I've done some basic things, not much more. That being said, we'll start to see a decrease, we'll start to see an increase on the energy waste from that particular asset. So we start to look a little deeper, and I said, well, have you ever thought about combining and technology and looking at either the power quality on the 480 or even looking at thermal imaging and your vibration, trying to combine two technology to make sure you get a complete picture. Well, it so happened, they come to find out on the next visit, we brought a thermal imager, and then we started scanning some of those, and come to find out that indeed the temperature on the bearings were fine, but the temperature on the center part of the motor was way above what it should have been. And normally we would look anywhere between 120 and 150 range would be just fine on the skin of the motor, because the difference between the core of the motor and then the skin is often maybe 35 to 36 degrees difference. So if you have 120, you have around 156 at the core of the motor. Well, if your temperature increase above 160 or even reach 200 degrees at the core of the motor, you could potentially have insulation degradation. That's often a common one that we hear from our customers. And it so happened that in this situation, even so the vibration were not showing any indication, the thermal imager were really concerning. And so we did a little more diagnosing and come to find out we were able to plan a PM with the customers to actually remove that motor, do some repair, not having a downtime because we could use a different part. And so that allowed the customer to save some time, save some money, do some pre-planning, and come to find out that indeed, in this particular situation, the insulation had degraded to the point then it was about probably a few weeks or a few months from completely failing. And so those are the things that I was explaining to our customers to say, as you're building your program, start combining some of those technology where it actually has a good fit, and maybe have a vibration and a thermal imager where you need it, and have both of those data feed into your own CMMS, so you can actually have, for the next time you have data, then you can track and look at it, and then refer to. And so whoever is a technician can go back to that particular asset. What have we done 3 months ago? Ooh, we had a high tap. I need to take a look more closely, and you can do the same work. And that can be incorporated into a regular PM structure within a work order. So those are the ideas right here. What I wanted to mention is that it's great to build a program, and once you build, you can actually combine multiple technology, really, and collect some good data. They really can affect what you are doing with your overall CBM. I think we came to the end. I hope then we have enough time. If there's any question, I'll be glad to take some questions. But I wanted to turn over back to Jorge to see if there's any questions.
Hi, everyone. You can hear me, right, Frederick? Hello?
Yes.
Okay. We do have one question. You were talking about the different tools. What's the best tool to get started if you really don't have anything, is in your advice?
That's a tricky question. And the reason why it's a tricky question, there's a number of tools that you can start with. I think then it has to do with the current training that some of the maintenance team have and the comfort level that they have. What we do see often is a lot of team feel comfortable using a thermal imager. So they've started with a thermal imager beyond the basic electrical tools. The thermal imager, it's fairly easy to get trained, even to attend a level 1 thermal imager. But even so, before that, before you attend a training, you can actually have some really good online courses within a few hours or even a day, where you can actually train yourself and start looking at some of the pictures and data that you're seeing. And obviously, pictures is a million word. When you look at it and you see an asset who is overheating, it's really easy for a technician engineer to really see, okay, we need to do something about this. Vibration tend to be slightly more, can be a little more difficult, requires a little more knowledge. But again, as we're moving forward, I see more and more where vibrations based on the technology that is being created and released from both a hand-to-hand and wireless, then a lot of companies coming out with, advanced diagnostics, machine learning, where it really help any technician figure it out and telling them where they need to take the action. So I think to answer your question, it really depends on the training they currently have, the comfort level, and I think the last piece is really with the budget. Some of these, a thermal imager can be now purchased for probably as low as $1,000 or $1,500, and as expensive as $10,000. 15 years ago, it was you can get anything for less than $8,000 or $10,000. So it really, the price have really come down on some of those technology. And so a combination of these two for maintenance managers to start and feel comfortable.
My only addition to that is, what's your most expensive piece of equipment that, or is most sensitive if it fails, and then you have to figure out what's the right tool for that particular equipment, right?
Yes, it's a very good point, and often this is a discussion that we have, is that, okay, do we invest about having a handheld tools that we can do a preventive on a regular basis, time calendar, or because this piece of equipment, if it goes down, will cost us $500,000 per day, then at that point, I would rather have a wireless or wired 24/7 condition monitoring sensor on it.
That's actually the next question related to that.
Okay.
The question is, we already have some fixed sensors on critical equipment. Is that enough for a PM?
I would say it's a great start, but I think then having a combination between obviously a preventive maintenance and also an existing program where you have either wireless or wired sensor on key assets. Um, I think it's a good balance. It's a good mix. Obviously, you're not gonna only take care of your tier one asset within a facility. A tier two, tier three asset, which is what we refer to a tier two or tier three, is semi-critical or non-critical. Any of these assets within a facility often are almost as important than a $1 million generator or chiller. And the reason why is that I've seen many times where you have maybe a $5,000 motor. Well, that motor on itself is not as critical, but if that motor goes down, takes 3 or 4 other systems who will take the whole process down, that's a problem. And obviously, that's why you're looking at it often upstream and downstream. How is this asset affecting my upstream or my downstream processes?
Okay, anyone else that might have questions, please feel free to use the chat tool here. The last question I have so far is, can you talk more about getting buy-in from my team? And I guess this person's having trouble getting budget money. Any advice beyond what you talked about?
So the budget money is always a big one. It's always a one that is not really easy to answer. And the way we approach this is in two ways. Now, I touch a little bit on it. As often is sometimes you're part of the beta trial. A beta trial was a customer, was a supplier. They may have a beta trial. They let you be part of it, and you can show. I think then even if you don't have a beta trial, is have a trial program. There's a number of companies who, if you buy just a very few basic tools, and it could be a combination of handheld and a wireless, where for maybe $2,000 or $3,000, you monitor a couple of assets, and then you can see the trend of all these assets. So think about it of a few assets you have had difficulties, or you're suspecting that you have potentially failure based the way they have been used or not properly used, the way they have been installed, whatever the reason, and you want to focus on this. Having a very, very small investment where you can show then if you put these tools in return, you can get data. That data can be a good indication of either prevent a failure, actually has shown a failure, and you were able to see it, or truly has a predictive aspect where 2 months down the road, we know that this motor has and will degrade. And so there's a lot more between hardware and software, things that we can do, which is fairly low cost, then an organization can start to invest a little bit and show return on investment. And often, even maintenance manager that we talk to have discretionary money that they can actually spend in that aspect in order not to take too much time, too much resource and money, but still show some return on investment. And then build a case, say, hey guys, I've shown that this motor, we're able to save $1,500 or $2,000 in labor and parts because we reacted ahead of its failure. I save shipping costs as well. And so you can take a case like this, and then you can show the net savings into the management, and the management say, hey, can we apply this to not only to 3 motors or 3 assets, but maybe 50, and then let's take it from there and start building up. And again, it goes back to start small and really grow, and you'll be able to show some of those savings.
I like the talk about the shipping. You know, overnight shipping of heavy equipment is could be considerable. That's all the questions I have. So, and we're running out of time, so I'll end it here. And you have everyone, you have my email and phone there. If you go to our website, tequipment.net, and you type in IWH course, there is a part number. I set it up like a part number. The full class webinars that we've done, as well as the slide decks, are all there for the last year or two that we've been doing these. So there's a lot of interesting webinars that maybe you can catch up on, as well as we'll be posting this one in a day or two. Again, thank you for chatting with us, and Frederick, appreciate your time, and it was a great presentation.
No problem. Thank you.
Okay. Oh, someone's asking me to put that link in the chat, which I will do right now. That way you have it. 1 second, folks. Okay. Send to all. I think that should do it. If not, you'll get it in the follow-up email. Again, thanks to everyone. I'll end the chat now. Thank you, Frederick.